Properties and proving parallelograms. For the first one, we're going to find the value of x in the parallelogram. So we know that this is a parallelogram. So these opposite sides are parallel. And in a parallelogram, the opposite angles are congruent. So x is also up here. And if we want to find x, we would set the consecutive angles are supplementary. So 60 plus x is going to equal 180 because of the consecutive angles supplementary theorem. So subtract 60 and x equals 120 degrees. In this next example, we just have to set the different parts of the parallelogram equal to each other. Since the diagonals bisect, we know these parts are congruent and BE is congruent to ED. So AE is 3x, EC is y, DE is 4x, and EB is y plus 7. So those are your two equations. Now we have our system set up. So we can solve by substitution and put the 3x in for the y. So we have 4x equals 3x plus 7. Subtract the 3x over. And you have x equals 7. Once you have x equals 7, you can take that and plug it in for the x and find y. So 3 times 7 equals y. So y is equal to 21. And that is what you needed to solve for this. So x equals 7 and y equals 21. For the next example, we want to find the measures of the numbered angles. This is a parallelogram, so we know that if we have some of the angles, then we can prove the other angles. We know these are parallel, and these two sides are parallel. So using alternate interior angles, we know that this 1 is going to be the same as this 3. So if we could just figure that out, then we should be able to do that. We have vertical angles right here. The 78, it would also be the same as that one. Then we have this triangle. So we should be able to solve for angle 3 because we have 78 here, 48 in the other corner, and then the angle 3. So the measure of angle 3 plus 78 plus 48 is equal to 180. So the measure of angle 3 equals 180 minus the 78 minus the 48, which is equal to 54. And if measure of angle 3 is equal to 54, then measure of angle 1 is equal to 54 because of alternate interior angles. Now I just need to find the measure of angle 2, which we can find using supplementary angles right here. So measure of angle 2 plus 78 is equal to 180 because they are supplementary. So subtract the 78. And the measure of angle 2 equals 102. For this next example, we want to find the value of x and y that makes this figure a parallelogram. In order for this to be a parallelogram, the diagonals have to bisect each other. So once again, we're going to set the bisecting parts congruent to each other. x equals 2y, and 5x minus 4 equals 2x plus 14. Now, if we would want to at this stage, we could do a substitution and substitute in the y and then solve for the y. But since there are no y's in this second equation right here, we could just go ahead and solve for x right away and then substitute in and solve for y. So that's what I'm going to do. I'm going to subtract my 2x from both sides, leaving me with 3x minus 4 equals 14, and then add the 4 over, and 3x equals 18, divide by the 3, and x equals 6. Now once I have x equals 6, I can take that and put it in right there and then solve for y. So 6 equals 2y, divide by the 2, and y equals 3. So your answer is x equals 6 and y equals 3. For these last examples, we want to be able to say if we can prove that the quadrilateral is a parallelogram based on the information that we have. So in this picture, we have the diagonals here bisecting each other. So we can say that this is a parallelogram. And my reasoning would be the converse to diagonals bisect. Theorem. In the next example here, we have one pair of opposite angles congruent right here, but we don't know anything about the other set of angles. So in this one, we would say no, because we don't have information about the other pair of angles. So that is it for the lesson on properties and proving parallelograms. So you should be able to complete the worksheet and be ready for your quiz.